Questions 1 through 10 on the 2004 Grade 10 AMC 10B. Each row of the Misty Moon Amphitheater has 33 seats. Rows 12 through 22 are reserved for a youth club. How many seats are reserved for this club? So we have rows 12 through 22. Now, how many rows is that? That's 11 rows. And each of those 11 rows has 33 seats. So 11 times 33 is 363. And therefore, this is the number of seats that are reserved for this club. And therefore, number 1, the answer is C. How many two-digit positive integers have at least one 7 as a digit? So if it's a two-digit number, the 7 can appear either here or it can appear here. So let's look at numbers that are 2 digits where the 7 appears in the first position. Those numbers are of the form 70, 71, 72, and so on. Now, how many of these guys do we have? It was a total of 10 of them. Now let's look at numbers that are 2 digits but have the 7 in the second position like that, or the units position, or the last position. Well, 07, how about that? No, because this is not a 2-digit number, so can't use that one. But you can use 17, 27, 37, and so on. Now, how many of these do we have? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So what's the total? 10 plus 9, which is 19. Yes or no? No. Don't choose 19 and move on. Why? Because there's one that I overcounted. It's this guy right here. You see how they're in both lists? So that cannot be counted twice, right? So in the end, we've got to subtract 1 from there to accommodate for that double count. So the total unique numbers is 18. So number 2, the answer is B. At each basketball practice last week, Jenny made twice as many free throws as she made at the previous practice. At her 5th practice, she made 48 free throws. How many free throws did she make at her first practice? So 1st, 2nd, 3rd, 4th, and 5th practice. Each time she makes double the amount, right? Twice as many free throws. So on the first practice, let's just say she made X free throws. Second practice, she would have made 2X. Third practice, double that, which is 4X. 4th practice, double that, which is 8X. And then 5th practice would be the double of 8X, which is 16X. Now they tell you that at her 5th practice, she made 48. So basically this is equivalent to 48. So 16x is equal to 48, like that. And therefore solving for x would be 48 divided by 16, and therefore x is equal to 3. Now they want you to figure out how many free throws did she make in her first practice. First practice, she made x free throws, and x, we just figured out, was 3. So she made 3 free throws in her first practice. So number 3, the answer is 3, and that would be choice A. A standard 6-sided die is rolled, and P is the product of the 5 numbers that are visible. What is the largest number that is certain to divide P? So what I'm going to do is just make a little table here. I've got my bottom number, the number that is not visible as in terms of what you can see if the die is sitting on the table or wherever it's sitting on. So that's my first entry. And then the visible numbers. And then, of course, what is the product of the visible numbers? So, for example, let's say I roll the die, and the 1 is the bottom number. That's the number I can't see. The visible numbers, obviously, are 6, 5, 4, 3, 2, and their product is 720. All right? So I hope that makes sense. If the bottom number is 2, the visible numbers on the die are 5, 6, 5, 4, 3, and 1, and their product is 360. And in a very similar way, you just keep filling this out. 6, 5, 4, 2, 1. Product will be 240. And then if the bottom number is 4, the visible numbers will be 6, 5, 3, 2, 1, and that product is 180. And if the bottom number is 5, visible numbers are 6, 4, 3, 2, 1. Product is 144, and you're an expert at this point. Bottom number is 6, visible numbers are 4, 5, 4, 3, 2, 1, and the product is 120. So what they're saying is that these are the P's, right? These guys right here. What is the largest number that is certain to divide P? So what number of the answer choices can go into any of these? All right, let's go through these. Let's go in a backward direction. Let's start with this guy first. 720 is a pretty big number. It would divide 720, but 360 over 720, that doesn't work, right? Because that does not give you an integer. So that's wrong. How about 144? Well, that would be a problem here. 120 divided by 144 doesn't work. It doesn't give you an integer value. So that's wrong. So we're left with 24, 12, and 6. All right, well, 24, let's see. If you take 180 and divide it by 24, unfortunately, it doesn't give you an integer. It gives 7.5. So, therefore, 24 is not right. Now we're down to 6 and 12. And the good news is that 12 does indeed divide into each one of these and giving an integer value. So 12 is the answer to number 4. In the expression c times a to the power of b minus d, the values of a, b, and c and d are 0, 1, 2, and 3, although not necessarily in that order. What is the maximum possible value of the result? C times a to the power of b minus d, and we've got 0, 1, 2, and 3 to work with. And we want the maximum, right? So if we want the maximum, this guy here, d, has to be the minimum. That's just the way it works, right? So I'm going to make d equal to 0. That's my minimum from my list that I can choose from. So now let's concentrate on c times a to the power of b. And we can very quickly write out all the possibilities. 1, 2, and 3 like that. 1, 3, and 2. 2, 1, and 3. 2, 3, and 1. And finally 3, 1, 2, and 3, 2, 1. Right? Really quickly. So that's 8. That's 9. This is 2. This is 6. 3, and 6. So as long as I didn't make any mistakes in my math, it seems like the largest one is this guy right here. And that happened when c was equal to 1, my a was equal to 3, and b was chosen to be 2. So the maximum result is 9, and therefore number 5, the answer is D. Which of the following numbers is a perfect square? Just in case you're not familiar with factorial, n factorial is basically n times n minus 1 times n minus 2 all the way down to ... to 1. So for example, if I have 7 factorial, it's 7 times 6 times 5 times 4 times 3 times 2 times 1. All right? I'm sure you knew about factorial, but just in case for those who are watching that don't know about factorial. Now, they've given us a bunch of numbers, and each of these basically is a product, just in case you're wondering. So a little dot should be there like that. So the first one, for example, will be 98 factorial multiplied by 99 factorial. So we want which one is a perfect square. Now, first and foremost, let's look at the individual numbers, right? Are any of those a perfect square? And they don't really look like perfect squares, right? So we have to manipulate one of these answer choices. We have to make it into a format where it will be clear that it's a perfect square. So for example, 99 factorial is basically 99 times 98 factorial. You see what I mean? Like that. And if you can do that, then we will be able to show that one of these is a perfect square. So I'm going to concentrate on something that will give me a leftover number that's a perfect square. All right, let me show you what I mean. Let's look at the first one, 98 factorial times 99 factorial, right? The 98 I'm going to leave alone, but the 99 factorial, I'll break it up into 98 factorial times 99, just 99 by itself. This is equivalent to that. Okay? Now, this 98 factorial and 98 factorial, we can put them together like this, squared, times 99. Now, this guy here is a perfect square. It's something squared. But what about 99? Is 99 a perfect square? And the answer is no. So therefore, this, unfortunately, is not a perfect square. But I think, hopefully, you get an idea of which one would be. And with a little bit of practice, you'll be able to figure out that if you take 99 factorial times 100 factorial, and you do the same thing, it will work. And I'll show you how. This is basically 99 factorial times 99 factorial times 100, just 100 by itself. These 99 factorials can be combined like that, squared, times 100 factorial, not factorial, just 100 by itself. But 100 can be written as 10 squared, correct? And then we can combine 99 factorial and 10 and put them all to the power of 2. And this is indeed a perfect square. It's basically any number, any integer value multiplied by itself. And therefore the answer to this question is C. On a trip from the United States to Canada, Isabella took D US dollars. At the border, she exchanged them all, receiving 10 Canadian dollars for every 7 US dollars. After spending 60 Canadian dollars, she had D Canadian dollars left. What is the sum of the digits of D? So 7 USD, US dollars, over 10 Canadian dollars, CAD, is D USD, which is how much she took, over a certain amount of Canadian dollars that I will denote as X, since I don't know yet. And therefore, if I cross multiply, 7X is equal to 10D. And X is equal to 10D over 7. Okay? And this is X, 10D over 7. This is Canadian dollars. I'll just put that in brackets there. This number here. Remember, D was our original US dollars, and then when she exchanges, she gets 10D over 7 Canadian dollars. And then she goes to Canada and she spends, of this amount, she spends $60, 60 Canadian dollars. And when she does that, they're saying she has D Canadian dollars left. So D, like that. This is the mathematical equation that you need to solve. Okay, so no problem. Let's do that. Let's see, we can get a common denominator. Lots of ways of doing this. Multiply through by 7. Let's multiply through by 7. I think that might be easy. So we get 7, 420, and 7D. 10D minus 7D is equal to 420. And therefore 3D is equal to 420. D therefore is equal to 140. 140 is the amount of Canadian dollars that she has left. Now they want you to find the sum of the digits of D. No problem. The 140, the sum of the digits would be 1 plus 4 plus 0, and that is equal to 5. So number 7, the answer is A. Minneapolis St. Paul International Airport is 8 miles southwest of downtown St. Paul and 10 miles southeast of downtown Minneapolis. Which of the following is closest to the number of miles between downtown St. Paul and downtown Minneapolis? Okay, so we've got an airport, and initially it is in a direction exactly southwest. So if this is St. Paul, it's basically here 8. And then we've got another airport, the same airport I should say, and it's exactly 10 southeast this time from Minneapolis. So I've got Minneapolis here, and this is 8 and this is 10. Now these terms southeast and southwest help us a lot because they basically mean that we're dealing with a certain angle. So if I were to kind of complete this diagram like this, then I will show you that these angles are basically going to help us figure this out. Southwest basically means that you're going down 45 degrees. And this is 90, so therefore this is 45. Southeast essentially means that you're going to be going at an angle of 45 degrees. And despite the crookedness, this is 90, and therefore this is 45. All right? So therefore this angle in here is 90 degrees. Okay? And all you have to do now is just basically figure out the straight distance between the two cities. And that would mean this guy right here. And you can easily do that with Pythagoras now. So we've got, I'll call that D. And D squared is equal to 10 squared plus 8 squared. And that's 100 plus 64, which is 164. And D is therefore 169 is 13 squared, so it'll be a little bit less than 13, so whatever, 12.8 maybe. And they just want you to figure out what is it closest to, so it's closest to 13. So number 8, the answer is A. A square has sides of length 10, and a circle centered at one of its vertices has radius 10. What is the area of the union of the regions enclosed by the square and the circle? So this is my diagram. I've got a square of length 10, so this is 10, this is 10, and then you have a circle that is centered at one of its vertices, so right here that's the center of the circle, and it has a radius 10, so it basically means that the length of the square represents the radius of the circle. And they want you to figure out the union of the regions, so this entire region, so everything that you see. Okay, no problem. We can easily do that by figuring out the area of the square and the area of the circle. The only thing is that when we do that, if we add them, we will double count this region. So we will have to subtract that. So it will basically be our union area will be the area of the square plus the area of the circle. Subtract from it the shaded area of the shaded region. Why? Because we double count that, so we have to subtract it once. Area of the square, pretty straightforward, 10 times 10, I hope. And the area of the circle is pi r squared. R in this case is 10. And the area of the shaded region, if you can see, is basically pi r squared, but you're going to divide by 4. Why? Because it's basically a quarter of a circle. So this basically becomes 100 plus 100 pi minus 25 pi. And that becomes 100 plus 75 pi. And I think that's it. So number 9, 100 plus 75 pi is B. A grocer makes a display of cans in which the top row has 1 can and each row lower has 2 more cans than the row above it. If the display contains 100 cans, how many rows does it contain? So we've got 1 can, and then you've got 2 more in the next row, and then 2 more than that row, and so on, right? So if you have row and number of cans, it's pretty obvious that in row 1 you'll have 1, in row 2 you'll have 3, in row 3 you'll have 5, in row 4 you'll have 7 cans, and so on, right? So what that basically means is that if you get down to row n, it will be 2n minus 1, the number of cans, and n minus 1 would be 2n minus 1, which is basically 2n minus 3. So that's the relationship between the row number and the number of cans. Okay, so they tell you that the total display has 100. So if you were to add up all of these guys, it would be 100, and they want you to figure out what is the value for n. Okay, so 100 is equal to 1 plus 3 plus 5 plus 7 plus dot 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 all the way up until 2n plus 1. Correct? So how do we proceed now? Well, there's lots of ways. I think what I like to do is kind of just pair them. That's the way I've always done it. And in order to pair them, I'll just add one additional one in the middle here. So the second last one, 2n minus 3, that one, 2n minus 3. And of course, there was a whole bunch of dot dot dots in here. Well, maybe not that many. Now, if I pair them, watch what happens. I'm going to pair the first one with the last one. Okay? Then I'll pair the second one with the second last one. And then so on. If you do that, you will see that each of these pairs becomes just 2n. And so on like that. Now we have to figure out, pretty straightforward, how many of these guys did I put originally? Well, I put n of them, correct? And then if I paired them, how many pairs did I have? Well, half of n. So I have n numbers here, and then I have n over 2 pairs here. And each of these pairs is equal to 2n. So n over 2 times 2n is basically the sum. And that equals 100. And therefore 100 is equal to n squared because the 2's cancel, and therefore n is equal to 10. And you can verify this. If there's 10 rows, you can make a table 1, 2, 3, all the way till 10. And for each of these, you can write out how many cans there'll be. And for 10, it'll be 2n minus 1, which is 19. And if you add them all up, you will see that it does indeed equal 100. So number 10, the answer is D.